Hi, can you all hear me OK? Awesome. Hey, everyone. I'm Kanu Gulati, and I'm going to speak on the opportunities in the Zettabyte era. I work at a fund called the Zetta Venture Partners, and we invest in enterprise software that learns from data, and we call it Intelligence Enterprise Fund. Industry analysts have predicted that the annual IP global traffic will exceed 1 zettabyte in 2016. This is what is called the Zettabyte era, where in addition to the amount of data and the characteristics of data, lots of other things, the business models, how you approach problems, where to focus on, a lot of other components changes. And that's what I'm here to talk about. And I will be focusing a lot on the industrial Internet of Things, or the IoT. We think that intelligence is the fourth era of computing. To preface that, the first era was the hardware. That was in the 1980s, which was the production of semiconductors that enabled us to quickly process data. The second era was the development of software to process real-world applications. The third was the distribution of computing to significantly reduce costs and allow the development of new types of software. The fourth era is the intelligence, which combines large volumes of data with cloud or distributed computing and with intelligent learning solutions. And this is what we call the intelligence era. Just as all workflows became software in the 1990s, we are convinced that all software is now quickly becoming analytical. This is the outline of my talk. I will begin with some of the drivers of this new era, talk about the implications of this new era on business models, roles, and product development, but focus the bulk of my talk on the opportunities which arise in industrial analytics. In addition to the growth in data, there are several other drivers to this fourth era of computing. The recent results in learning and natural language processing solutions and the rise in number of mobile or handheld solutions are often cited about, and you must have all read about it. I really want to bring attention explicitly to three other drivers. One, the rapid growth in the number of public data sets. In the last few years, the number of public APIs that have been launched in the current administration has been more than 193,000. Similarly, the rise of cloud computing. More than 50% of all enterprise apps today are now hosted on the cloud. And third, the number of connected devices. It's now rapidly approaching 50 billion in the next few years. All of these drivers, in addition with learning solutions, algorithms, et cetera, are playing a huge part in the advent of this intelligence era. This, in turn, has implications on business models and roles in the enterprise. One of the biggest implications of intelligence is that analytics companies build proprietary data sets, which, when applied along with the core business model, builds defensibility that organically grows with more usage and more data. Just as Google's defensibility is achieved by intelligently collecting and applying query logs, is today one of the hardest to challenge. Another implication of the fourth era of computing is that every role on the board today requires data and intelligence-driven tools and solutions to carry out their activities. Some of these roles already have tools that integrate intelligence, but these are open opportunities for all the entrepreneurs in the room looking for where to invest their time. A pretty broad sense of open opportunities are also in data science development and collaboration. For example, data scientists today still struggle with deploying the models to business cases because data science tools today don't integrate well with current software. Similarly, data scientists, for them to collaborate with each other is still a challenge because the joint versioning of code and data is still not a solved problem. Solutions that require large volumes of data to train struggle with the cold start or the bootstrapping problem. And delivery of data in real time requires new distribution models, which are all open opportunities. However, in this talk, I want to focus on the open opportunities, which we have realized looking at hundreds of companies in this space and talking to a lot of customers, which we think are still unaddressed. The Industrial Internet of Things, or Industrial IoT, connects the physical world of sensors, devices, and machines in our industries to the internet. It enables unique objects to collect and analyze a variety of data. The insights generated from this data using analytics are singular and valuable and can fundamentally transform businesses and technologies. Industrial analytics are predicted to grow at a 30% CAGR over the next decade. And there are several reasons. Some of them I've already covered, generally in reducing costs of hardware, reducing form factors, improvement in big data tools and infrastructures, and a variety of other reasons are causing a rapid growth of Internet of Things. This framework is our way of trying to understand where are the new opportunities and where are the current companies being built in this space. The industrial analytics framework, in our view, is on the top layer is the data or the knowledge generation layer, and the bottom layer is the analytics application layer. This is a very abstracted view. The leftmost column is the streaming analytics, which is data collection from a variety of sensors and devices. This could be data such as temperature, humidity, pressure, or electrical measurements. And this is gathered and stored and streamed to data management systems, which here is labeled as analytical database. These are designed to ingest millions of events per second. These systems allow data aggregation, cleaning, storage, and real-time comparison of multiple streams and with historical values and models. Analytical database, in conjunction with monitoring systems and visual data exploration systems, which are labeled as visual analytics on the chart, enable discovery and learning from this data, which can be useful in updating historical models or in identifying anomalies. When a specific anomaly or a condition appears, it can result in an automatic action, such as a trigger or a digital adjustment, or an alert, which is designed by the reporting system. Today, human supervision is quite indispensable in all of the aspects here. And the challenge is in automating almost every component here so that we can work with the machine-generated data and at that rate. One of the areas of gap that we've identified is data warehouses today are simply not designed to handle high velocity of streaming data. Most of this new data is unstructured and with no standard data or versioning systems. Both historical and real-time data is required in order to understand the scenarios and take appropriate actions. To delve further into this problem, there are multiple reasons why this is a huge problem. Today, you're integrating data from multiple sources. This data could be available in data warehouses, in public databases, in global web-based systems, and you have to integrate legacy data with real-time event or time series data. These sources often contain redundant data in different representations, and there are no clear winner in techniques which can provide filtering, querying, schema translation, aggregation, or migration today. Another reason why this problem is very complicated is because newer schemas are increasingly getting hybrid. So traditionally, the schema on the left used to be employed to aggregate data from a variety of sources. The data warehouse approach, which would offer a tightly coupled architecture because these data is already physically reconciled in a single queryable architecture. However, more recently, newer schematics have been employed, which favor loose coupling between hybrid data sets and provide a unified interface to access real-time data over a mediated schema. The sources in this mediated schema are hybrid. They're not the same kind of databases. They could be both open source or commercial solutions. And to further complicate this problem, as mentioned previously, both the characteristics of data and applications are evolving. So increasingly, applications require analysis done on this more complicated, more voluminous data in real time. Analysis of streaming data is today required at hundreds of gigabytes per minute, and results honestly can't wait for batch processing. And instead of processing serially, imagine the power of processing data and queries in parallel or using predictive or probabilistic methods. And so these are the areas where I think are big open opportunities for entrepreneurs and investors to invest in. Coming back to the same IoT analytics framework, another area of open problems are solutions that allow decentralized decision-making in industrial workflows. This is because analytics in general, IoT and analytics, require an intense two-way flow of information in order to coordinate and manage a huge conglomerate of producers and consumers of data, and everyone in between. In order to not overload the system, decisions should be made as close as possible to the source, which creates the need for decentralized decision-making capability. Actions need to be performed quickly, autonomously, and without human intervention or error. Solutions could be in the form of intelligent edge computing or mobile computing in industrial workflows. This is some of the sample problems and possible intelligent solutions which I hear from other companies, from potential customers. Begin with responding in real time, so being able to run algorithms on streaming source data. Prioritizing among incidents, so incorporating information among previous courses of action to determine what's worth investigating next. Modeling user behavior, an intelligent solution there could be to model behavior and compute risk scores at the individual user level, and then adapt these models as behavior evolves towards mobile and decentralized and more collaborative solutions. Another problem is finding vulnerabilities before being exposed. Solutions here could be using neural networks to act like human responders and therefore exploring all applications. And another problem is managing in multiple entry or endpoints. And a potential intelligent solution here could be to set up neural networks to explore all endpoints. These are very high-level problems and solutions which I'm listing, but this is what I hear from customer interviews in industrial Internet of Things. Another area of application which is also ties back to this decentralized decision-making is in trying to improve the efficiency of analyzing correlations. So oftentimes, false or redundant alerts reduce the efficiency of data-driven processes. There are limited commercial solutions that identify the source of an anomaly. What is required for this are basically a fast anomaly detection, quick regression and correlation analysis, and causality inference to identify the source of that problem. And once you have identified the source of the problem, corrective actions can be taken, and the analytics loops can be sped up. But again, today there are no good, clear winners in solutions which enable analyzing correlations really quickly. To quickly cover some of the risks of investing your time and resources in analytics, one of the risks are focusing on solutions with either of these things, like with unclear proprietary data acquisition strategy, lack of advanced analytics and statistics experience, particularly in learning solutions, insufficient compliance and governance of data, or reliance on a previous generation of compute infrastructure to solve today's problems. All of these are huge risks when I look at investing in opportunities in IoT. Another big area of risk is an over-focus on specific technology trends. In general, it's always harder to pick industry and market trends than just broad generation-defining technology trends. So we like to invest in more market trends, and I'd implore you to focus on where the markets are shifting and spending your time and energy and resources on that spaces. And to summarize, today it is the new era of computing, the intelligence era, which combines huge volumes of data with software, with learning solutions, and distributed computing. There are major implications for this era on the enterprise, for business leaders' roles, product development, and deployment. And specifically, opportunities in industrial IoT, which I've listed here, are around two areas. One, systems that aggregate real-time data streams and legacy disk data. And two, scalable solutions that allow decentralized decision-making in industrial workflows. Thank you. We have a few minutes for any questions. Hi.
So when you talk about the valuation of the IoT space industry-wide, we see a lot of numbers thrown out there from trillions to 50 trillions. I've seen all kind of numbers. What do you think about these valuations? Because these valuations are done from today's standpoint, and they don't factor in many aspects that when you are dealing with such a huge volume, the price point is going to go down. So today what you value at 70, 80%. So how do you see from investor point of view those kind of values?
So to repeat your question, you're saying that today the valuation of IoT solutions is unfairly high and you think it's going to fall down. Is that your question?
I think it is very high, and just wanted to see what you think on it, or what is your take on it. Because think about it, right? Whenever there is a huge scale, the economics of scale, the moment you have scale, price points will drop dramatically. But right now what we see, oh, billions of connected devices will connect and generate so much of revenue and so much of savings. But when you really have that implementation, that price point will go down because you are going to generate that much of sensors, connectivities. So the economic of scale will bring down that.
So the way you would value a company, a solution in IoT, would be the impact it's having on an organization and its ecosystem and the vendors and its customers. So a lot of the community, and I definitely believe that, especially in industrial IoT, we're just beginning to scratch the surface in what data we are collecting and even looking to analyze. I believe McKinsey did a report last year. It said today not even 1% of all of the IoT data that's being collected is being analyzed. And in some ways, you're speaking to my initial thought that most of the value is in analytics and in using insights from that data to make your solutions better, and so improving both the top line and reducing the costs. So my in fact understanding is the valuations today, I don't know if you're pointing to any particular valuations, and we can talk about those offline, but in general I think IoT is still a very, in itself, an open opportunity. People have just been trying to understand that how do I even collect all that data, and analyzing that data hasn't even started in the true sense, and applying those to have a quicker feedback is again a big wide open opportunity.
So you're saying the data itself is not being collected enough as of now, that generates a lot of questions. So that will in a way sustain that valuation, what we are talking about.
The insights from that data combined with learning solutions, combined with the distributed computing infrastructure we have today, yes, that value will only improve. Thank you. Sure. There's a question on the back there.
And trying to overcome them. So do you have pointers for companies that already exist, or do you know of companies who are trying to get an end-to-end real solution to all these problems? I would say that I know a lot of companies that are focusing on one aspect of that problem, but not all the problems, and certainly not actually going for the big companies that are struggling with all of these things that you mentioned because, well, they were funded or founded 20 years ago, and they didn't have this in their vision, right?
Right.
Any thoughts about those two things?
Yeah, so you're absolutely right. Like a lot of the bigger companies today, if you see some of the biggest investments in IoT are by companies from corporate VCs, from companies such as GE and Tyco and Siemens, and that's because they are the first people who are facing those challenges, and they're trying to identify where I can find solutions. And so, I'm out here to come and tell people that these are still unsolved problems. They can start with trying to solve a tiny solution, but the idea effectively should be to generate insights to continue having, building your defensibility, and that's why I talked about the defensible models, such as Google when compared to Informatica, and how do you apply those insights back? But you have to start somewhere, start one of these challenges, such as this data aggregation and cleaning in IoT is a huge challenge. You can start with that and say, for a particular vertical within that, solve that problem and grow your defensibility by collecting data, and you become the best solution to, say, providing data cleaning and aggregation for IoT or providing context for IoT, and then grow from there.
Do you think startups are the ones who are going to solve this problem, or do you think that they want to put more money into this problem?
Well, there's a reason I work in venture capital is because I think startups out there are just more efficient, faster, can try out new products, models, and solutions. And big companies are just too sluggish and slower, so that's where the advantage of being in a startup is. So, yeah, I'm definitely bullish on startups to solve these problems.
All
right.
I'll take so,
one last question. I think we're out of time.
What I noticed that real-time or near real-time data versus the legacy batch-oriented processing. There is some challenge, that in terms of investing the extra money for bringing the data real-time. Do you see a lot of those demands are coming, and if it is, from which industry are those? I mean, retail did a pretty good job, I know. But what else? What about the other industry? Do you see there's...
Yeah. In fact, I see increasingly these demands of real-time processing. And real-time is a very fluid term. People use real-time sometimes for a day's data and sometimes do milliseconds data. So near real-time, where I talk about it like milliseconds, is required for, say, when you mentioned retail, but also in general, say, the energy and the transportation industry. Like trucks today have so many sensors, and to collect that data in real time to provide the right guidance to the truckers' information, the routing, et cetera, has to be done in real time. Similarly, dynamic pricing, what is needed by Ubers and all of the shared economy, like on-demand economy, just changes drastically if you can really do real-time pricing as opposed to batch processing historical data. So increasingly, there's so many areas that is moving towards real-time, and it's still a struggle, but that's where the opportunities are. So happy to talk more about it offline, and areas which I see a lot of companies or areas which I still see are open. Okay, thank you.